Math 171, Module 1, Graphs of Composite Functions. In this question, we are given a graph with two lines. The orange line represents function f, and the green line represents function g. The first problem we were asked is to find f plus g at 1. So what we have to do is find f at 1 and g at 1, and then add them together. Let's look to the graph to find these. This position is where x equals 1. Let's draw a line upward. If we draw the line upward, we intersect the orange graph here at 3. So we can say f1 equals 3. We intersect the green graph here at y equals 1. So we can say g1 equals 1. If we add both answers together, we get 4. So we can say f plus g at 1 is equal to 4. We can do the same thing for the next question, f minus g. We are given -1, so let's find f at -1 and g at -1 and subtract them. Let's go to where x equals -1 here and draw a dotted line downward. We intersect both functions at the same time here at y equals -1. So we can say f at -1 is -1. G at -1 is also -1, but now we subtract. We have a double negative here in the second line, so we can treat this as -1 plus 1 instead. This gives us 0, so we can say f minus g at -1 is equal to 0. Let's go on to this somewhat unusual looking statement. We have g and then a circle and then f at 0. This circle is called the composite operator. To do this, let's first start with the inside, f at 0. Here is where x equals 0, and the orange line is function f, and we can read directly from the graph a y value of 1. So f at 0 is 1. Then we move on to the next letter, g. We write g and then pass in the answer above. So we're really looking for g at 1. Last time we looked at x equals 1, we found that it intersected the g line at 1. So that will be our answer to g composite f at 0. First we find f at 0, and then find g for whichever answer we got. In the next example, we have f composite f at 0. So let's first start on the inside, f at 0. We found previously that was 1. Now we go to the next letter. We have an f next, and we pass in the answer we just got. That's 1. So now let's look to f at 1. We already have a dotted line here at 1, and we can see that this dotted line intersects the orange function f here at 3. So our answer will be 3. So we can say f composite f at 0 is actually 3.